Hello dear students, Assalamu alaikum. In this video, I'm going to discuss some multiple choice questions from CAIAS Physics, Winter 2022, Variant 1-1. Question number 3. In an experiment to determine the acceleration of free fall g, the time t taken for a ball to fall through a distance s is measured. Percentage uncertainty in the measurement of s is 2%. Percentage uncertainty in the measurement of t is 3%. And the equation is also given. You have to find out the percentage uncertainty. Now, for finding out percentage uncertainty, when the uncertainty of the physical quantities of your equation is given, the procedure for finding out the percentage uncertainty is very simple. Like, all you have to do, you just need to consider the physical quantity, displacement s, and time t. So for s, the percentage uncertainty is 2%. And for t, percentage uncertainty is 3%. But in case of t, as there is a power, t square, so in case of applying the value of uncertainty of time, you need to multiply that uncertainty by 2, as the power is 2, t square. So 2 into percentage uncertainty is 3%. Now, if the power was like that, like t to the power half, in that case, you need to multiply that 3% with half. If the power of time was 3, then you need to multiply that 3% with 3. Okay, so you have to take the power of the physical quantity in consideration when finding out the percentage uncertainty, and also to find out the fractional and absolute uncertainty. Now, you don't have to do anything with the value, with the numerical value that is multiplied with the equation. All right, so that 2 or 3 or 4, whatever the value is in the equation, that value doesn't have any participation in the equation. All right, so the result is going to be 2% plus 6%. So that means overall 8%. So the answer is going to be C. So let's move on to question 8. This question is quite interesting. A massive serpent 2 kg is suspended from the lower end of a light spring. A second massive serpent 1 kg is suspended from the first mass by a thread. The arrangement is allowed to come into static equilibrium, and then the thread is cut. Immediately after the thread is cut, what is the upward acceleration of the 0.2 kg mass? Now, at first, according to Newton's third law, what is the downward force? Downward force is the total mass is 0.2 plus 0.1 multiplied by acceleration due to gravity, so 0.3 g. Now, as the downward force is 0.3 g, so the tension force that is acting in the spring is going to be 0.3 g. Now, immediately after the thread is cut, the thread is in between 0.1 and 0.2 kg. Immediately after the thread is cut, what is the upward acceleration of the 0.2 kg mass? Now think about that. At the current position, the tension force that is acting on 0. If you just consider this object, if you just consider 0.2 kg object at current situation, if you draw a free body diagram, the tension force that is acting is 0.3 g. And the downward force that is acting on that object is 0.1 g. That means the weight of the smaller object. All right. Now, when the thread is cut, just immediately when the thread is cut, the tension force is still 0.3 g. Just when the thread is cut, still the tension force that is acting on 0.2 kg object is 0.3 g. But as The serpent 1 kg object is removed as the thread is cut. So the downward force now acting on that 0.2 kg object is going to be 0.2 g, itself weight. So if you want to find out the acceleration, apply Newton's second law. That means resultant force. In Newton's second law, this F is resultant force. So resultant force is the tension force that is acting in upward direction, 0.3g, minus the weight of that object. I mean the object that we are considering, 0.2 kg mass. So that's 0.2 g. Mass of that object is 0.2 into acceleration. So if you solve it from here, the answer is going to be 0.1 g divided by 0.2. So that's 4.9 meter per second square. So answer will be A. In question 11, you can say that there's two square board length of one square board is x and length of another square board is twice x, hangs freely from a nail P as shown. The board has uniform thickness and is made from material of uniform density. Both the board is made from material of uniform density. Now the question is, they're also hung from the point P and Q that are at same level from ground. So we need to find out the vertical distance between the position of the center of gravity of the two board. Now, as both the board are square board and they're hung freely from point P and point Q, so the center of gravity will be at the middle because it's square. So the center of gravity will be the intersecting point of both the diagonals. So this will be the center of gravity. This will be the center of gravity for the smaller board, and this will be the center of gravity for the bigger board. Now the question is, what is the vertical distance? What is the vertical distance between these two center of gravity? So that means we need to find out this distance. We need to find out this distance. So at first, let's find out the length of the diagonal of each of the boards. So for smaller board, the length is going to be root over x squared plus x squared so root over 2x. And for bigger board, now this is the length of the diagonal of each of the board. Now we need to find out the distance. So we need to find out from this distance to that distance. All right, so that means half of the diagonal. So we need to subtract the half of the diagonal of the smaller board from the half of the length of the diagonal of the bigger board. So the answer is going to be length of the diagonal of bigger board, you need to divide it by 2 minus length of the diagonal of the smaller board, again you need to divide it by 2. Then you will get the distance between the vertical distance between the center of gravity of smaller and bigger board. Okay, so root over 2x minus root over 2 by 2x. Now if you use the calculator, the answer is going to be root over 2 by 2x. But there's no answer in that option. Why? Because you need to simplify it. You can simplify it. Root over 2 into root over 2. x root of x by root of 2. Now be careful. When you calculate in calculator, the calculator will always give you answer in the short form. I mean, there won't be any root over in the denominator position. You will get the root over related number at the numerator position, but in the option it is given x by root over 2. So you can simplify it and find out your correct answer. Okay. So let's move on to next question. The density of water is 1 gram per centimeter cube, and density of glycerin is 1.3 gram per centimeter cube. So water is added to a measuring cylinder containing 40 centimeter cube of glycerin. So the density of the mixture is 1.1 gram per centimeter cube. We don't know that how much water is added. We need to find it out. What is the volume of the water added? That's the question. Now, the density of the mixture is given 1.1 gram per centimeter cube. So the density of the mixture, we can write down. The density of the mixture equals to total mass divided by total volume. Let's consider x gram of water is added. So x plus, now the density of glycerin is 1.3 gram per centimeter cube. That means 1 centimeter mass of 1 centimeter cube of glycerin is 1.3 gram. So mass of 40 centimeter cube of glycerin will be 1.3 into 40. Now volume. The density of the water is 1 gram per centimeter cube. That means the mass of 1 centimeter cube of glycerin is 1 gram. So that means mass of x, volume of x gram of water is going to be x centimeter cube. Because the density is 1 gram per centimeter cube. That means 1 centimeter cube volume, corresponding mass is 1 gram. So if the mass is x gram, the corresponding volume is going to be x centimeter cube for water. All right, so plus, and volume of glycerin is 4 centimeter cube. Now we just need to find out the value of x. If you simplify it, the value of x is going to be 80 gram. Now, as the density of the water is 1 gram per centimeter cube, so that means the volume of 80 gram of water is going to be 80 centimeter cube. So 80 centimeter cube of water is added to the mixture. Now, question 15. It's a very good question. A box in the shape of a cube falls from a ship into the sea. The box lands with its lower face level with the surface of the sea. The box begins to sink. So at first it was at level with the surface of the seawater. The box begins to sink, becomes totally submerged, and then sinks deeper into the sea. Submerged means the upper level of the box is with the level of the water, but then it sinks deeper. That means it's totally into the water. As the box sinks, its lower face is always parallel to the surface of the sea. That means this surface and the water surface is always parallel. Which graph best represents the variation of the upthrust acting on the box with the depth of its lower face below the surface of the sea? So we need to find out the relation between the upthrust and also the depth. I mean, the depth of its lower face, below the surface of the sea. Now, how we can find out? So to find it out at first, we need to know about the upthrust. Now, what is upthrust? Upthrust is the weight of the displaced fluid. Upthrust is the weight of the displaced fluid. And the formula is rho Vg. Rho is the density of the fluid. V is the amount of displaced fluid or the volume of the object. Volume of the object. Or volume of the displaced fluid. Volume of the displaced. Now look at the first figure. The object has just hit the surface and no part of the box is into the water yet. So in that position, the upthrust that is working on the object is 0. Why? Because the formula of upthrust is, as I've discussed earlier, volume. So volume means volume is actually that volume is the volume of the displaced fluid by that object, by that box. Now, as this is a cuboid, so in the place of volume, we can write down cross-sectional area multiplied by length or height. That length or height is the amount of height that is into the water. That is into the water. If you look at the first diagram, so cross-sectional area is A, but no length of that object, no height of that object is still into the water. So upthrust is right at the moment 0. But while it is descending, think about it, while it is descending, the amount of length or height that is into the water is going to increase. So upthrust will also increase. And when it is fully submerged means the top surface of the box is at the level of the top surface, at the level with the surface of the water, then the whole height of the object is into the water. So in that case, at the position of volume, you can put the value of volume of the whole box at the as the whole box is into the water. Now from the submerged position, when it is sinking, the amount of displaced fluid is not changed. So when the object is submerged and then it's sinking, the value of the upthrust will remain constant because the length of the object or height of the object that is into the water is not being changed. So upthrust won't be changed. So look at the formula again. Density of the water is fixed, constant. Cross-sectional area of that object is also constant. G is also constant. But L is different while the object has just touched the surface of water and it is sinking. And when it will be in the submerged position, I mean the moment from touching the surface of the water to the moment when it is fully submerged, that means the top surface of the box is at the level with the surface of the water. In this time period, the upthrust will increase. So for this time period, you can write down upthrust is directly proportional to length of the box that is into the water. But when it is submerged and then when it is sinking, the upthrust will remain constant. So if you look at the graph, you can clearly understand the answer is going to be C, because we can see that upthrust is directly proportional to length. Upthrust is directly proportional to length or height of the object, right? So upthrust will increase linearly. It will increase linearly, but when the object is fully submerged, after that, the upthrust is going to be constant. Okay. So you can have confusion between the options C and D, but answer will be C. It won't be a curve. Why it won't be a curve? Because look at the relation. It's directly proportional. So at first it's going to be a straight line, but when it will be submerged and after that the upthrust will remain constant. Doesn't matter at what depth the object is now. Okay. Fine. So answer is C. Let's move on to next question. So in question 22, when a guitar string is plucked, it causes a longitudinal wave in the air. The speed of the sound in the air is 340 meters per second. What is the approximate frequency of the sound wave shown? Now we know that in case of longitudinal wave, in case of sound, so there will be region of compression in air molecules, and there will also be region of rarefaction. And this series of compression and rarefaction causes the sound to move from one location to another location. Now the speed is given 340 meters per second. What is the approximate frequency? So the formula for any wave, the formula relating velocity, frequency, and wavelength is V equals to F lambda. Now we know the velocity, that is 340 meters per second. We need to find out frequency. What we can do, we can find out the wavelength from this figure. So how? Now the distance between the center of two consecutive compression is a wavelength, and also the distance between center of the two consecutive rarefaction is also the wavelength of that particular sound wave. So compression is the place where you will get cluster of molecules. The molecules will remain very close to each other, and that is the compression region. So the center of compression region here you can consider. So this is a center of compression, and next immediate compression is here, and the center you can consider as 0.5 meters. So this is the wavelength. So in case of sound, the distance between the center of the two consecutive compression is a wavelength, or distance between the center of two consecutive rarefaction is also this figure. It's better to consider two consecutive compression region. Why? Because it's comparatively easier to mark the center of the compression region. But in case of rarefaction region, it's difficult to mark the center. You will get the result. Close to the correct answer. But still, compression region is very clear, and you can easily mark quite correctly the center of the compression region. So that's the wavelength, which is 0.5 meter. Now simple, apply the formula. V equals to F lambda. Velocity is 340, that is given. Frequency, we don't know about it. Lambda is 0.5 meters. So if you simplify, the value is going to be 680 hertz, which is the correct answer. Okay, fine. Let's move on to the next. Okay, so in this question, a transverse wave travels along a rope. The diagram shows the rope at time t equals to 0. The wave is traveling from left to right. Period of the wave is t. And one of the particle is identified here as x at point x. Which graph shows the variation with the time of displacement of the particle x between t equals to 0 and t equals to twice t? So it's just they're talking about a single particle at position x, or particle x. Now, in case of this type of question, at first you need to understand the direction of the particles movement or particle vibration. You need to find it out. So what you can do, or what I always do, extend the wave and keep it in sine form. Now always remember, these particles are moving in this direction, and in this section the particles are moving in that direction. So point at x is moving in downward direction. So this direction is fixed. If the profile of the wave is like this, then the corresponding particles in the wave will move like this. So we can say that at current situation, at time t equals to 0, the point x is about to move in downward direction. So the initial displacement is going to be negative. Initial displacement is going to be negative, and we need to find out the displacement of the particular particle at x, or particle x. So it will move in downward direction. then it will get back to its original position, then again it will move in upward direction, and it will again move in downward direction. In upward direction, it will come back, and again it will move in downward direction. So if you consider the profile, they're asking about to draw the to find out the displacement time graph that for that particular X, which is vibrating in a vertical direction. So what can be the corresponding displacement time graph? It's going to be B. It's not going to be A, because X is moving. Look at here, X is moving in downward direction. So starting displacement is going to be negative. It cannot be positive. If there is a point like Y here, then the answer would be A, because the point is moving in upward direction, so positive displacement. So be careful about it. Okay. So the answer is B. Let's move on to the next question. Question 27. Question 27 is not going to be a difficult question for students who really understand how the stationary wave is formed and what does the nodal point and antinodal point represent. So here you can say that closed end tube, one end is open and one end is closed, and a standing wave or a stationary wave is formed inside that tube, and the length of the tube is L. Now the question is asking about finding out the variation of the amplitude with respect to distance x from closed end towards open end. And if you look at the options, you need to find out the profile up to the actual length of the tube. So up to the antinodal point. From the closed end up to the open end, what is the variation of the amplitude with respect to distance from the closed end? Now, in case of standing wave, move like this. Like say, for example, in case of standing wave, this half cycle will move downward direction, that half cycle will move in upward direction. Downward direction, upward direction. Okay, so at nodal point, so here the graph will be, here the formation of the standing wave will be like this. Because at nodal point, zero displacement. And at antinodal point, maximum possible displacement. So here, nodal point. And again, antinodal point, here, the displacement is maximum, so amplitude. So, we will get amplitude at this antinodal. So the answer is going to be A, because only the profile of A is matching the condition that is stated in the question. So answer is A. Let's move on to the next question. Question number 31. So in question 31, a length of wire RS has a circular cross section, and R of the wire cross sectional area is A, and at end S cross sectional area is A by 2. Charge Q takes time T to pass through end R of the wire. There is a constant electric current in the wire. At any position of the wire, the value of the electric current is constant. How much charge will pass through end S in a time interval of T by 4? That's what we have to find out. Now, there is a key information, that is, there is a constant electric current in the wire. At any section of the wire, the current is constant. That means at any section of the wire, the amount of charge that is passing with respect to time, that ratio has to be constant at any cross section of the wire, because the current has to be constant. Fine, so we can write down I1 equals to I2. I1 is the current that is going through the cross section at R, and I2 is the current that is going through the cross section of S, or let's write down IR equals to IS. Now I've said that the value of the current is constant. That is already stated in the question. So I equals to Q by T. So Q amount of charge is passing through time T. Then in smaller section, cross-sectional area is A by 2, but actually you don't have to think about the cross-sectional area. Why? Because it is saying what is the amount of charge that is passing through the end S in a time T by 4. So look at here, the left side ratio and the right side ratio, that has to be equal. So if you think about the quantity of charge in this section, that has to be Q by 4. Otherwise, the right side ratio is not going to match with the left side ratio. And it has to be equal. Why? Because in the question, it is already stated that there is a constant electric current in the whole wire. All right, so how much amount of charge is passing through S? That's Q by 4. So answer is going to be B. Let's move on to next question. Now, this is a very good question. Question 36. For solving this question, you really to understand how the voltage and current gets divided in a circuit. Now here, no power supply is given. The magnitude of the power supply is not given. And we can say a voltmeter. The reading of that voltmeter is 0. We need to find out the value of resistance R. We need to find it out. Now, when the voltmeter gives the value of 0, when the potential at this point and this point is same. So for simplifying the problem, let's reorganize the circuit. So this is the setup. Now think about it. If the supply voltage is 20, this whole section is gonna get 20 volt because it's parallel with the circuit. And this whole section is also going to get the whole 20 voltage. But if you consider this, say for example, loop number 2, the voltage here is going to be double to the voltage of 5 ohm. Why? Because the resistance is double. As the resistance is double, the voltage is going to be double. So say for example, if the supply voltage is 30, you will get 10 volt here and you will get 20 volt here. All right, because resistance is double, so you need to spend more energy to move unit coulomb of charge through that resistor. All right, so 20 volt, 10 volt. So resistance is double. So think about it. The potential here and the potential here has to be same. If the value is same, then no current will flow through that wire and the voltage is going to be 0. So that means as the resistance here 10 ohm is double to 5 ohm, the total resistance in this parallel circuit has to be double than 2 ohm resistance here. All right, so that means this particular parallel resistors, the total resistance has to be 4 ohm. because this is 2. This is 2. If this is 4, then you will get 10 volt here and 20 volt here. Now, as this is 10 volt and this is 10 volt, so the potential at this point is same and no current will flow. So that means 1 by, that's the total resistance, 4 ohm, 1 by 4 equals to 1 by R plus 1 by 8. So if you solve it, the value of R is going to be 8 ohm. Or you can simply think like that, if this is 8 and if this is 8, the result is going to be half of one of the resistor. Okay, that is 4. So the value of R is going to be 8. If you don't understand it, just watch the video again. It's a very important question. If you solve it properly, it's going to help you to solve a lot other questions in other paper. Okay, so let's move on to the next question. In this question, a battery of electromotive force 6 volt and negligible internal resistance is connected to a voltmeter and 4 other components as shown. The voltmeter is connected between the points X and Y. Positive terminal of the voltmeter is connected to X and negative terminal of the voltmeter is connected to Y. And resistance of each of the resistor 1 kilo ohm. It's given in the question. Which change on its own will cause the voltmeter to show a positive reading? I mean, you have to make a change here, and that change has to cause a positive reading in the voltmeter. So how we can do it? I mean, there are 4 options, and obviously one option is correct, for which the voltmeter can give you a positive reading, and you have to find out that correct option. Now, if the voltmeter should have a positive reading, then the potential at point X has to be higher than potential at Y. Now, how we can achieve that? Because now, according to question, resistance in each of the resistor is same, 1 kilo ohm, 1 kilo ohm, 1 kilo ohm, 1 kilo ohm, right? So that 6 volt will be divided equally. That 6 volt will be divided equally in both the resistor. 3 volt will be dropped here, and 3 volt will also be dropped here. And same thing will happen here as well. So 3 volt, 3 volt. So the potential drop after 3 volt, this section is having 3 volt left. So potential is 3. And here, after dropping of 3 volt, you are still having 3 volts. So as the potential is same, so the voltmeter reading is going to be 0. If you want to have a positive reading in the voltmeter, then the potential at X has to be higher than potential at Y. Now, how we can achieve that? Clearly, the answer is going to be C. Why? Because, say for example, we are not changing anything in this section. I mean, first resistor, we are not changing anything. So the potential drop is same. So 3 volt in the first resistor. So available voltage is 3 volt. Vx supply voltage is 6 volt. And out of that 6 volt, 3 volt is dropped in the variable resistor. So we are left with 6 minus 3, 3 volts. Available voltage at X is, or available potential at X is 3 volt. Now, what about Y? Now, if we decrease the light intensity, if we decrease, this is LDR, light dependent resistor. If you decrease the light intensity, the resistance is going to increase. If the resistance increases, then the potential drop will increase. Previously, the potential drop was 3 volt. Why? Because the resistance of this LDR and this thermistor was same. But as we are decreasing the light intensity, what will happen? It will cause increased resistance, which will cause increased potential drop. Say, for example, 4 volt. So if the potential drop is 4 volt, so now the available voltage at Y will be 6 minus 4, that's 2 volt. Now, the voltage at X is higher than the voltage at Y. So this is high potential, this is low potential, then we will have a positive reading in the voltmeter. All right, so the answer is going to be C. But if you do any other thing from the 3 options like A, B, and D, The answer is, I mean, we cannot have a positive value in the voltmeter. Why? Like, look at option A. Decrease the temperature of the thermostat. Decreasing the temperature will cause increased resistance in thermistor. Now think about it. Out of 6 volt, 4 volt is spent here. Then 2 volt will be spent here. So after spending 2 volt here, we are available with 4 volt. And at X it was 3 volts. Then the voltmeter will give you a reading, but that's definitely not going to be a positive reading. It's going to be a negative reading because the terminal is positive and negative. But at Y, at negative terminal, we're getting high voltage. At positive terminal, we're getting comparatively low voltage. So the voltmeter is going to give you a negative reading. So if the question was like this, which change on its own will cause the voltmeter to show a negative reading, then A will be the answer. Let's look at option B. In option B, increase the resistance of the variable resistor. Now, if we increase the resistance of the variable resistor, what will happen? So 3 volt, 3 volt. We are increasing the resistance of the variable resistor. So initially it was 3, but as we are increasing the resistance, say for example 4, 2. So we are spending 4 here, we are left with 2 volt here, and there is 3 volt here. So again, we will get a negative reading. So if the question was about negative reading, then the answer can also be B. So in that case, definitely both option A and B won't be here. Only one of them will be here as a right answer. They'll give one option definitely, and they'll give another option. They'll make a new option. If the question was said like the way I have discussed just now. 100 ohm resistor. All right, so initially the resistance of each of the resistor is 1000 ohm, so that's 1 kilo ohm, and here 0.5. So here resistance is double, so the potential drop has to be double, like 4 volt, 2 volt. So after spending 4 volt here, 2 volt will be available here and 3 volt will be available here, because here the resistance is same. We didn't change if we consider option D. So what will happen? We will again get negative reading. So for option A, B, and D, the voltmeter will give a reading, but that's going to be a negative reading. But the question is asking about positive reading. So that's why the answer is going to be C. That's a very good question for understanding the division of potential in each of the resistor. If you don't understand it, try to see this video again and again. I hope you'll understand. So let's move on to the next question, question number 38. An alpha particle passes close to a gold nucleus. The question is from alpha particle scattering experiment, and is deflected through an angle greater than 90 degrees. We know that very few of the alpha particle get deflected with a deflection more than 90 degrees, approximately 1 out of 8,000. Anyway, which property of the alpha particle changes as a result of the deflection? Now think about it. Alpha particle itself is positive. Nucleus is also positive. So alpha particle is being deflected with a deflection greater than 90 degrees. So which property of the alpha particle changes as a result of the deflection? Now here, the alpha particle is not exactly colliding with the nucleus, but for changing of momentum, always direct collision is not necessary. There just have to be action and reaction force. When two objects is interacting, whether they're directly colliding or not colliding, if there is just a presence of action and reaction force, then definitely there can be a change in momentum. Like here, alpha particle is positive, nucleus is also positive, so they're going to repel. So collision is not necessary. When alpha particle is getting closer to the nucleus, because of electrostatic force of repulsion, both of them will apply force to each other. So there is clearly electrostatic force of attraction. There's clearly action and reaction force in form of electrostatic force of repulsion. All right, so definitely there will be a change in momentum, and an alpha particle is changing its direction. So there will be a change in momentum. There won't be any change in charge or nucleon number or proton number because they are not colliding. If they were colliding, then there can be a change in charge, nucleon number, proton number. But as they are not colliding and alpha particle is changing its direction because of electrostatic force of repulsion, so there will be a change in momentum. Look at question 39. A nucleus of 23892 uranium decays in stages by emitting alpha particles and beta particles, eventually forming a nucleus of lead-206. How many alpha particles and how many beta particles are emitted during the decay chain? Now, when alpha particle is emitted from a nucleus, there will be a change in both mass number and in atomic number. But in case of beta emission, there won't be any change in mass number. So that means 238 uranium (206 lead). So this change in mass number is only occurring because of alpha emission. So from that decreasing of the value 238 to 206, we can find out how many alpha particles are being emitted, right? So 238 minus 206, that's 32. In each alpha emission, how many protons and neutrons emitted? 4, right? So 32 divided by 4. So there are 8 alpha particles. So the answer is going to be either A or B. Now let's find out beta particle. Now, as we are confirmed that 8 alpha particles are being emitted, so that means proton number will decrease by 8 into 2, 16 proton number. So 238, 92 uranium. So from 92, atomic number 92, if we subtract 16, it's going to be 76. 92 to 76, but we can say that it's not 76, it's 82. We know that in each beta emission, proton number will increase by 1. In each beta emission, proton number will increase by 1. So that means there has to be 6 beta emission. There has to be 6 beta emission, otherwise it cannot be increased to 82. So that means answer is going to be A. Okay, let me give you a short brief again. At first, you will find out how many alpha particles are being emitted, and you can do that because in case of alpha particle, emission, there will be change in both mass number and atomic number. But in case of beta emission, there won't be any change in mass numbers. So from 238 to 206, you can find out that 32 particles are being emitted. 32 protons and neutrons, and in each alpha particle there is total 4 protons and neutrons. So if you divide 32 by 4, you are getting 8 alpha particle. So when 8 alpha particle is being emitted, the atomic number is supposed to decrease by 16, but we can see that it's not decreasing by 16. From 92, it was supposed to be 76. If you subtract 16 from 92, it's supposed to be 76, but it's 82. That means there are 6 extra proton. So from where we can get that 6 extra proton? If there is 6 beta emission. In each beta emission, proton number increases by 1. So from 76 to 82, we need 6 protons. So we require 6 beta emission. So answer is going to be A. List of particles contains only fundamental particles. Now we know that fundamental particles are particles that cannot be broken down into new particles or other particles. Now this is actually, you need to memorize the information. Which particles is fundamental particle and which particle is not. You need to know about it. So look at option A, antineutrino, beta particle, and meson. Now here, antineutrino and beta particle, these 2 particles are fundamental particle, but meson is not. Why? Because there are 2 types of hadron. Hadron particles, are particles that are affected by strong nuclear force. And two types of hadrons are there, baryons and mesons. Mesons is composed of two quarks, one quark and one antiquark. So clearly meson is not a fundamental particle because you can break it down to other particles. So option A is not correct. B, that's also not correct because baryon, neutrino, and positron, they're fundamental particles, but baryon is not because it's hadron and it is made up of quark. So the fundamental particle is quark. In baryon, the fundamental particles are quarks. So B is not correct answer. Question C, electron, neutrino, and alpha particle. Alpha particle definitely not a fundamental particle because there are protons, neutrons, and proton neutrons are not also fundamental particles because they're made up of quark. So clearly C is not the correct answer. So we are left with D. D should be the correct answer. Leptons are particles that are not affected by strong nuclear force like electron, positron. So these are fundamental particles because you cannot broken down into more simpler particles. Quark, this is also a fundamental particle. Positron, positive electron, that is also fundamental particle. So this is the correct answer. So you need to memorize it. Okay, otherwise it will be difficult to actually find out the correct answer if you don't memorize the properties and composition of each of the particle. So that's all for today. I hope this video will help you. And if you have any suggestion, you can write down in the comment section, or if you want any particular paper to be solved, you can write down in comment and I'll try to solve it and upload the video. Thank you very much. God hafiz.